In this video, we'll explore 25 research papers that have made a huge impact on computer science. We'll put these groundbreaking papers into groups to make them easier to understand. For each paper, we'll talk about the key ideas and why they matter, giving you a quick overview of their significance. So, let's get started. First up, let's check out the papers that changed the game for distributed systems and databases. The Google File System paper introduced a highly scalable distributed file system built to handle massive data-intensive applications. GFS can handle failures while using inexpensive commodity hardware, and it delivers high performance to many users. It's different from traditional file systems because it expects failures to happen. It optimizes for large files that are frequently appended to and read sequentially, and it uses chunk replication to keep data safe. This innovative approach has set the stage for modern big data processing systems. The Amazon Dynamo paper introduced a highly available key-value store designed to scale across multiple data centers. By prioritizing availability over consistency in certain failure scenarios, Dynamo uses techniques like object versioning and application-assisted conflict resolution to maintain data reliability. This approach has inspired many other NoSQL databases, including Amazon's own DynamoDB. Bigtable and Cassandra demonstrated what distributed NoSQL databases could do by efficiently managing structured data at a massive scale while ensuring high availability and fault tolerance. Bigtable, developed by Google, is known for its low latency performance and scalability, making it perfect for large-scale data processing and real-time analytics. On the other hand, Apache Cassandra, initially designed at Facebook, combines features from Amazon's Dynamo and Google's Bigtable, offering a highly scalable, multi-master replication system with fast reads and writes. Google's Spanner improved distributed databases by offering a globally consistent, highly available, and scalable system. It introduces the TrueTime API, which uses time synchronization to enable consistent snapshots and multi-version concurrency control, supporting powerful features like non-blocking reads and lock-free read-only transactions. FoundationDB introduced a new way to handle distributed transactions with its multi-model key-value store architecture. It is known for its ACID transaction across a distributed system, providing strong consistency and support for various data models. FoundationDB's layer design supports multiple data models on top of a single, robust core, making it very adaptable. Amazon Aurora pushed the limits of high-performance databases by separating storage and compute. This design allows for scalable and resilient storage that can automatically grow and shrink as needed. Aurora also provides high availability and durability, with 6-way replication across 3 availability zones, ensuring data integrity and fault tolerance. Next, let's talk about the papers that changed data processing and analysis. Google's MapReduce revolutionized big data processing by enabling the parallel processing of huge datasets across large clusters of commodity hardware, making it easier to handle parallelization, fault tolerance, and data distribution. Apache Hadoop, an open-source version of MapReduce, became a popular choice for big data processing tasks, using the same principles to handle large-scale data efficiently. Flink brought together stream and batch processing, allowing for seamless processing of real-time and historical data. It provided a powerful framework for building data-intensive applications by treating batch processing as a special case of streaming, offering consistent semantics across both types of data processing. Apache Kafka, developed by LinkedIn, has become the leading platform for distributed messaging and real-time data streaming. It enables the creation of reliable, scalable, and fault-tolerant data pipelines. It organizes data into topics, with producers publishing data and consumers retrieving it, all managed by brokers that ensure data replication and fault tolerance. Kafka's high throughput and low latency make it ideal for applications requiring real-time data processing. Google's Dapper paper introduces a distributed tracing system that helps troubleshoot and optimize complex systems by providing low overhead application-level transparency. It highlights the use of sampling and minimal instrumentation to maintain performance while offering valuable insights into complex system behavior. Google's Monarch is an in-memory time series database designed to efficiently store and query huge amounts of time series data. It features a regionalized architecture for scalability and reliability, making it ideal for monitoring large-scale applications and systems by ingesting terabytes of data per second and serving millions of queries. Moving on, let's explore the papers that tackle complex challenges in distributed systems. Google's Spark paper explained how Google manages its large-scale clusters. It introduced the concept of containers and showcased the benefit of centralized cluster management system. Uber Share Manager provides a generic framework for managing sharding in distributed systems. It simplifies the process of scaling and managing large-scale databases by adaptively adjusting shard placements in response to failures and optimizing resource utilization. Google Zanzibar is a global access control system. It efficiently manages access control lists across large-scale distributed systems. It provides a uniform data model and configuration language to express diverse access control policies for various Google services. Zanzibar scales to handle trillions of access control lists and millions of authorization requests per second. Facebook's Thrift paper explores the design choices behind their code generation tool. It highlights the benefit of using a common interface definition language to build scalable and maintainable systems. The RAF consensus algorithm provided an easier-to-understand alternative to Paxos. It simplified the process of building fault-tolerant distributed systems. The important 1978 paper, Time, Clocks, and the Ordering of Events in a Distributed System, introduced the concept of logical clocks. It establishes a partial ordering of events in distributed systems, providing a framework for synchronization events and solving synchronization problems without relying on physical clocks. Now let's explore papers that introduce groundbreaking concepts and architectures. Attention is All You Need introduced a transformer architecture in 2017. It has had a huge impact on natural language processing. The paper shows how effective self-attention mechanisms are. They allow models to weigh the importance of different words in a sentence. This innovation led to powerful language models like GPT. They have significantly improved tasks such as translation, summarization, and question answering. The Bitcoin white paper laid the groundwork for cryptocurrency and blockchain. It introduced the concept of a decentralized peer-to-peer electronic cash system and sparked a new era of digital currency and decentralized applications. Go-To Statement Considered Harmful, published in 1968, challenged conventional wisdom and sparked important discussions about programming language design. It argues against the use of go-to statement and advocated for structured programming practices. Finally, let's discuss some papers that focus on specific applications and optimizations. The Memcache paper showcased the complexity of caching at scale. It highlighted the challenges and solutions in building a distributed caching system to improve application performance. The MyRocks paper presented an LSM tree-based database storage engine. It demonstrated how to optimize storage and retrieval operations for large-scale databases. Twitter's Who to Follow service gave insights into building effective recommendation systems. It showcased the algorithms and techniques used to generate personalized user recommendations based on social graph analysis. The 2021 survey on vector databases offered an insightful look into this cutting-edge technology. It covered the basics, how they are built, and their various uses. It focused on how these databases are designed to handle and search complex, high-dimensional data efficiently. These papers represent just a fraction of the amazing research that has shaped computer science. They help us gain a deeper appreciation of the challenges, solutions, and innovations that have brought us to where we are today. If you like our videos, you might like our system design newsletter as well. It covers topics and trends in large-scale system design, trusted by 500,000 readers. Subscribe at blog.bytego.com.